Hello everyone, my name is Masood. I'm an engineering faculty at Ontariotech University, and this video is a tutorial for Simscape Electrical, which is a toolbox for MATLAB users, and we're going to use it in our power system lab. So I'm going to show you how to install the package on your MATLAB and how to create a model for a three-phase power system. Simscape has different packages in Simulink. It's got the electrical, specifically the three-phase electrical, but it could be also used for mechanical engineering, in hydraulic, in like a mechanical rotation, or in magnetic, or like a specialized power system. But our focus would be the three-phase like power systems. So let's go through the installation first. The installation is done directly through MATLAB. So you have to run the MATLAB and then go to add-ons and then click on get add-ons, and in the search box you have to type Simscape Electrical. So Simscape and then electrical. For me, because I have already installed it, it shows as installed add-on, but for you it's gonna come up as a new add-on. You can click on the picture and follow the directions to install the package. So I'm gonna start with creating a model. So you have to click on the Simulink, and when you click on the Simulink you have to click on a new, so like a new one, and then you can start from the electrical three-phase. So click on electrical three-phase. So a template model is going to be popping up. So the model that is popped up, it comes up with like a spectrum analyzer, line voltage sensor, so some basic units, but I'm not going to use any of them for now. We're going to start from basic, so I'm going to just simply delete all of them, and I'm going to start from like a simple RLC circuit, which is mainly the focus for our lab manuals. So double click on the model and type three-phase source. So the first one is three-phase source, and the three-phase source pops up here. You have the A and B and C lines. Then I'm gonna just again double click and say three-phase measurement, so VI measurement. So I'm gonna have a three-phase VI measurement, and what I can do, I can just simply connect A and B and C's together, so the lines are going to be connected. And VABC and IABC are the voltages and the currents for the three lines that you can like have here. So it gives you the voltage, and if you double click on this one, you can say which voltage, phase to ground or phase to phase. You can also, so I'm going to just keep it as the default. You can define to measure the current or not to measure the current, so I keep it as measure the current. Then I want to have a load, so double click it again, and you can say three-phase parallel RLC load for now, so parallel RLC load, and you can use the Control R a couple of times to rotate it to get the right direction. So this gives you an RLC for each line. So how do you define it? So you can define the active power, the inductive reactive power, and the capacitive reactive power. So for RLC, instead of directly defining the R and L and C, you can define by the powers, the active reactive for the different RLC. And the configuration you can define as Y with grounded or floating or neutral or delta. So I'm going to just choose it as, keep it as Y grounded, and I'm going to connect my ABC here. So I'm going to move it here, B to B and A to A, and C to C. So here basically whatever you define based on those power, the like active reactive powers, it calculates automatically RLC that are going to give you those powers, inductive and capacitive powers, and it would apply to all lines. So line A is going to have RLC, line B is going to have the same RLC, and line C is going to have same RLC here. And now let's say I want to measure the voltage and current, so I'm going to just double click and bring up the scope here. Okay, and I'm going to right click on it and say the number of ports, so signal and ports, number of ports defined as 2, because I want to be able to see both current and voltage. So I'm going to connect the current to the second channel and the voltage to the first channel. And then I forgot to configure the source. So the source is 60 Hertz. The RMS voltage, let's do it as 120 volt. And then this is a lot for the stop time, because 10 seconds is a lot when your frequency is 60 Hertz. So I'm gonna like define it as 0.1 Hertz, 0.1 seconds, sorry. And the other thing that you need is power GUI. So there is a block which is called power GUI, and you need to put it on any three-phase model. So this power GUI is just configuring the whole model, so you need a block to put in there. So now I'm gonna run it. After the running, you can see the waveforms for the three phases, for the voltages and for the currents. The big waveforms are for the voltages. They are shown in different colors of yellow, blue and orange. You can see the current is like small, because the scale of the current is much lower than the scale of the voltage. And the best bet is just to click on the gearbox for the settings and change the layout to by dragging of those two. So you see that the two waveforms, two windows are open like subplots. And then another thing that you can do, just click on the, make sure the maximize axis is auto and axis scaling is also auto, and then you say OK, and then you see that the current waveforms are shown on a separate window, separate plot, and it's auto scaled between -1 to 1, and the voltages are between 100 and -100 and hundreds. So the model that we created here practically showed us how to like develop a model in Simscape. But the fact is that the lab manual for Power System Lab is actually giving us the direct value for RLC. So if we use this load, the load that we have in this model, we have to calculate the active power for resistor, inductors and capacitor, which is going to be quite time consuming. So instead of doing that, I'm gonna delete this load and search for three-phase RLC branch. So three-phase series RLC branch, and I'm gonna connect it here. So if I double click on here, it's gonna say branch type RLC. You could just use only R, only L, RL, RC, or even open circuit. So let's keep it RLC, and the values of R and L and C are given. For example, R is 1 ohm here, 1 millihenry here, and 1 microfarad here. So you can change to whatever you want to change it. So let's keep it that way. So the load could be, what is like this three-phase series RLC block is giving you is 3 RLC for each line, and then you can connect them either in delta or in a star. So it's up to you. For now, I'm gonna just use the just simple Y. So all these 3 on the other side, I'm gonna connect it to the ground. So I'm gonna click search for the ground, And you can see we have lots of grounds, ground Simulink, ground HDL coder, but you have to choose the ground that is used for the three-phase. So ground, like a specialized power system, I would use this one. And then I'm gonna connect all this one. If I had chosen the ground from Simulink, then I had to use some converters to convert the Simulink to this power system from the Simscape. So to avoid that, try to use the blocks that are limited to Simscape, so you don't have to convert the Simscape block to the Simulink block. So now I have a three-phase RLC. They are connected in the Y connection or a star connection, and if I run it, you will see the voltages and the current waveform on the plot. And don't forget the settings needs to be the one that we set before for the two plots and the auto scale. Sometimes you need to do single measurements in the power systems, so having like module to do the three-phase measurement might not be a good idea. For those cases, what we use is the voltage measurement block. So you're gonna just click and search for voltage measurement, and that gives you a block with two inputs and one output. Let's say if you want to measure the voltage across like a load, so we know that one of the loads because now we are doing the a star connection, and one of the loads is going to be across B and C. So I connect the two inputs to B and C, and I can simply connect the output of the voltage measurement to a scope. Let's say if I want to measure the current going to the load, so I double click and search for current measurement block, because there is a similar block but this time for current. So I'm gonna just put the current measurements here, and for this one you have to put the current measurement block in series with whatever you want to measure the current. So let's say if I want to measure the current going to the load, I'm gonna delete here because I have to put it in series with here. So I have to cut the connection. So from one side is gonna go to the plus, and the other side is gonna go to the negative. So in this case the current goes here, goes to plus, and the negative side of the current meter goes to A. And this is the way to measure the current going to the load. The output for the current measurement is here, so I can connect it to maybe another one for the scope. So if I run the model, and if I open the scope, I can see the voltage and current. So let me close this one to show you how I got to this point. So the first thing I want to do, because you see that the current is very low, so it's better to go to the view and change the layout and make it like 2. Okay, and again you can see that the current is not shown properly in this one. So I'm gonna use this, click on the scale for y-axis, and you see the moment you click on the y-axis, the current is shown properly. So the top is the voltage, the bottom is current, and then you can go to tools and measurements and signal statistics. So with the signal statistics, a window is going to open up here. It says voltage measurement and current measurement. So if I click on voltage measurement, it's going to give me all the statistics for the voltage. For example, RMS is 119.7 volt here. If I click on current measurement, it gives me all the statistics. For example, RMS for current is 0.67 amp. If we want to measure the phase between current and voltage, let's say if the application is to find the cos phi. So in this case we need to do some cursor measurement. So for cursor measurement we go to tools, measurements, and we just activate the cursor measurement. So I'm gonna find out the phase difference. So what I do, maybe I click on like one peak, so the peak here, and then I bring the other cursor to next peak. For let's say this one, it would be the peak here. So this is the difference, maybe a little bit more accurate to go right on the peak. So delta t is shown as 4.49 milliseconds, so that's the delta t, and the period is 60 hertz. So simply you have to multiply this delta t by the period by 360, and that gives you the phase, and from there you can calculate the cosine of that to get the cos phi between voltage and current. And another application that you may need to use Simscape is to find the active and reactive. So there is a block for that. You have to just click on power measurement, and that gives you the power measurement. You can see that the active and reactive, so it's asking for voltage and current as the input, and it gives you the power, the P and Q, active reactive powers. So my voltage was here, so what I'm going to do, I'm going to connect to voltage here. That was my voltage, and the current was here, so I'm going to connect it to current. So voltage and current is given here, and then I'm going to connect the power here and Q to the scope. So I'm going to run it and open up the scope. Oh, sorry, I forgot to tell you about let me open up the thing and then I explain what I need to do. So if I do not set up the power measurement, you see that we are lots of power measurement, 1, 2, 3, 4. So this is basically because it's calculating the P and Q for all the harmonics, which is not something that we want for our lab at least. So what I'm going to do, I'm going to double click on the block and change the harmonic to only 1. So it would be 60 hertz and harmonic just 1, and say OK, and then I'm going to run it. Let me see if I did it. Okay, it's running now. So if I click here, you can see that there's only power measurement 1, which is actually the P, and power measurement 2, which is Q. And you see the statistic here. So power measurement 2, which is Q, the RMS for Q is 68 watt. And then you can switch this one. So the RMS for P is 5.1 watt. And of course, I'm not this was just an example, so the numbers might be like something that YP is less than Q. It depends what current and what voltage you pick. I just picked it up as an example to show you how to do the measurements. I guess that's about it for the Simscape tutorial, and I hope this is gonna help you with with the lab. And in case if we need to put more contents into this tutorial, I will add it later. Thank you very much for watching that video.